Hello, you're welcome to today's lesson, and today I'm going to start the binomial theorem. A binomial expression is the sum or difference of two terms. For example, x plus 1, 3x plus 2y, and a minus b are all binomial expressions. If we want to raise a binomial expression to a power higher than 2, example, to find a plus b raised to the power 5, we use Pascal triangle. Yes, under the binomial theorem, we'll also be bringing a Pascal triangle because that is what will help us to expand an expression very easily. Though we are going to be using binomial theorem when we have a larger number, that is when we have maybe a plus b. We have a plus b raised power maybe 30. In this case, you may not be able to use a Pascal triangle because the number will be large. Not that Pascal triangle is wrong, but we're supposed to use a binomial theorem where we have a kind of general formula that will help us to find some of the terms, or depending on the number given us. Then after that, and this can only take place if n is positive, we're also going to deal with the expansion that will involve n negative. But for now, let's see Pascal triangle. Now, as you can see on the board, Pascal triangle goes like this. 1, then you have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. The question now is how did we come about these numbers? And these numbers are the coefficients of the values that you get after expansion. For example, if you expand a plus b raised by 2, you are going to get something like this. And again, you discover that the first coefficient, which is 1, will have the highest number. It will continue to decrease until you get to the least. So let's take a plus b raised by 2, for instance, and then see whether we are going to arrive at this. You know that a plus b raised by 2 is the same thing as a plus b into a plus b. Now, if you multiply out, a times a is a squared, a times b, ab, b times a, ba, and b times b, b squared. And again, you discover that ab is the same thing as ba, just like 2 times 3 and 3 times 2, which means we can have a squared plus 2ab plus b squared. You can see that what we have here is exactly what we have here. And how? This one is the coefficient of this, and that's the first letter, having the highest power, which is 2. Then 2ab. You know, I told you all these things are coefficients. 2ab plus b squared. That's why you have 1, 2, 1. 1, 2, 1. Then the question is, how did I come about 1, 2, 1? Watch, you have 1 here, 1, 1, 1, 2, 1. This is how it goes. 1 plus 1 is 2. You go down. 1 plus 2, 3. 2 plus 1, 3. You have your 1, 1 again. Coming down, 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. We have 1 again. Coming down here, this is the fifth power. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. You have your 1, 1. So, for instance now, using this without multiplying out, let us see how we can handle a plus b raised by 3. Just going direct to what we have here, picking the coefficients. I told you the highest power will go with the first letter. It will continue to decrease until the final letter. Now, the final coefficient will now be the last letter, which is b, as we are having it here. So let's see and see how we can do it. Now, I want to use this method to write the value of this, which is what I have here. So I will now have a a plus b all raised by 3, which I will now have as, remember I'm picking this. This one will give me a raised by 3. The coefficient here is 1 plus 3. A will come in minus 1. Should be a squared b. Remember that in each case, the powers must add up to the highest power. This is power 1 and this power 2. 2 plus 1 is 3. Again, plus 3 again. 3a b squared. You can see the way it is going. And then finally, I have my b raised power 3. So my final answer is a raised power 3 plus 3a squared b plus 3ab squared plus b raised power 3. And then if you look at this, it's the same thing we have here. So instead of going through the stress of trying to multiply a plus b times a plus b times a plus b, if you write this, you will get this. At least it will be very easy to expand terms like from a plus b all raised power 2 to maybe 6, 7, 8, or 9. Because if I want to get that of 6, it's just for me to add the other one. So that is about that. For example, if I want to get a plus b raised power 6, for instance, what I will just do is I'll add my 1 here. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. And then you have your 1. So this will now lead us to a plus b raised power 6. And that is how you can make use of Pascal triangle. So that is about that. So now if we have x plus a raised by n to expand, for instance, then the binomial theorem for all values of x and a, provided n is a positive integer, is given as this formula. X plus a raised by n equal to x raised by n plus n combination 1, x raised power n minus 1, a raised power 1, plus n combination 2, x raised power n minus 2, a raised power 2, plus n combination 3, x raised power n minus 3, a raised power 3, up to n combination n, a raised power n. Again, I don't know whether you are conversant with factorial, but a kind of brief introduction. Let me explain it. So note Note, if I have n combination R is given as n factorial all over R factorial into n minus R factorial. Let me give an example. If I have 7 combination 3, for instance, this is the same thing as 7 factorial all over 3 factorial brackets 7 minus 3 factorial. And that is the same thing as 7 factorial all over 3 factorial 4 factorial. Remember that 7 minus 3 is 4. And then this thing will now lead us to 7 times 6 times 5 times 4 times 3 times 2 times 1. So 4 factorial is the same thing as 4 times 3 times 2 times 4 times 3 times 2 times 1. So then you are dividing by 3 factorial, that's 3 times 2 times 1, then times 4 factorial. And if you check, you discover that 4 factorial will divide all this. Then again, 3 times 2 is 6. So we divide this, remaining 7 times 5, which is what? 35. So I want to let you have an idea of what factorial means. And then take note that 0 factorial is equal to 1. You can check this in your calculator. 0 factorial is equal to 1. So you have seen it, how I worked it. So when we are using this formula, for instance, here, that's what we are going to be using so that you will not get confused. When we start solving examples, I will explain more of it. So that is about that. Let's move on. So we are now going to pick an example that will help us to see how we can solve it. So we are continuing by solving an example. So we have the first example on the board. Write down the expansion of x plus 2 all raised by 4, simplifying the coefficients. Solution. Using, that's the theorem, using the theorem. Using x plus a raised by n equal to x raised by n plus x raised by n minus 1 a plus n combination 2 x raised by n minus 2 a squared dash dash dash. We have we now pick this. We have x plus 2 all raised power 4. In other words, we are going to be applying this here. This is the binomial theorem, and we are going to apply this to this and see what we are going to get. So this will give us 4 combination 1, because our n is equal to 4. For combination 1, then x raised power 4 minus 1 into 2 raised power 1 plus for combination 2, x raised power 4 minus 2 into 2 raised power 2 plus for combination 3, x raised power 3 into 2 raised power 3. This one is wrong, please. This is 4 minus 3. And then 2 raised power 3. 2 raised power 3. Then plus finally, for combination 4, x raised power 4 minus 4, then 2 raised power 4. Okay, the explanation now. This will give us x raised power 4, which is the first one. Sorry, this is supposed to be x raised power 4 plus x raised power 4 plus. So we continue. Plus now we bring in this one. 4 factorial all over 1 factorial 4 minus 1 factorial. Then x raised power 4 minus 1 into 2 raised power 1. That is picking the whole of this. Plus now, again, we pick this one, 4 factorial all over 2 factorial bracket 4 minus 2 factorial. Then x raised power 4 minus 2 into 2 raised power minus 2. Plus now, we are picking this one, 4 factorial all over 3 factorial brackets 4 minus 3 factorial x raised power 4 minus 3 into 2 raised power 3 into 2 raised power 3. Or let me write it well here. That will give us plus 4 factorial all over 3 factorial 4 minus 3 factorial. Then x raised power 4 minus 3 into 2 raised power 3. Then plus, we are picking the final one now, 4 factorial over 4 factorial into 4 minus 4 factorial x raised power 4 minus 4, then into 2 raised power 4. Okay, so we are coming back from here to this place to simplify. We are coming back to simplify. So coming back here, we have from here now, we have x raised power n plus 4 minus 1 is 3 plus 4 times 3 factorial, or if you like, 4 times 3 times 2 times 1 all over 1 factorial, which is 1 times 1. 1 factorial, this should be 3 factorial times 3 times 2 times 1. Then x minus 1 is 3. X raised power 3, then into 2. So that will give us, this we divide. This is 1. And then 4 times 2 should give us 8. 4 times 2 should give us 8. So that we have that. And that will now be then plus, we work it out at the end, we bring it together. We are now bringing, we have solved this, we have solved this. We are now coming over to this. That will be plus 4 factorial, or sorry, 4 times 2 times 4 times 3 times 2 times 1 all over 2 factorial from here. Then again times 2 factorial, because this minus this is 2. Now x raised power 2 into 2 raised power 2. Again, you know that this time this is 4. So you remove this, and that will remain what? This is 6. 6 times 4, that's 24. So we hold it like that. Plus now, we are bringing in this. And that is 4 times 3 times 2 times 1 all over. This will be 3 factorial times 1 factorial. And then 3 factorial is from here. So you can, then this is x raised power 1 into 2 raised power 3. So that will give us this, we cancel this, remaining 4. Now, 2 raised power 3 is the same thing as 8. 8 times 4 is 32. So we leave it like that. Okay. Then finally, we pick this one. Plus 4 times 3 times 2 times 1 all over. Okay, there's no space there again. So let me clean it and go up. So the last one, we are going to come up here. We're going to come up here to now have that this last one plus 4 times 3 times 2 times 1 all over. We have again 4 times 3 times 2 times 1, because 4 factorial over 5 factorial. 4 minus 4 is 0 times 0 factorial. Remember that I said 0 factorial is 1. You can check it from the calculator. So then raised to our x raised to power 4 minus 4, that is 0 into 2 raised power 4. So if you carry out the whole thing, you bring out the answers. So coming back, this one will now give us x raised power n plus 4 times this is 8. So that will be 8 x raised power 3 plus, then you also check here, this is 6 times 4, that's 24. 24 x raised power 2, that is this. Then the third one, that is 2 raised power 3 is 8 times 4 is 32. Plus 32x plus this one is everything here we divide. X raised power 0 is 1, which means the only one that will exist is this. 2 raised power 4 is 16. So, and that is the answer. So we have x raised power 4, 8x cubed plus 24x squared plus 32x plus 16. So we have succeeded in expanding that, and we have arrived at the final answer. So that is how we can use binomial theorem to solve a question like that, to expand. If you check by using a Pascal triangle, you get this because it's just to power 4. Others may be bigger than that. So we can also go ahead to pick another question. Let me see. So, okay, we have come to the end of this part. Please like, share, comment, and subscribe. And if there's any question, you can put it in the comment section so that I'll look at it and find solution to it. In my next lesson, I'll solve more questions concerning the use of the binomial theorem. After solving some positive values for n, I will also pick some positive and negative and show you how to solve them before I finally go back to simultaneous linear and quadratic equations. As I said earlier, I would like you to please share, comment, and subscribe. My name still remains Harrison. Thank you.